Okay, this is note 6.6, translating quadratics. The first thing we notice is it's comparing graphs. So all of the graphs we'll be doing today are being compared against the parent graph for quadratics. And the parent graph for all quadratics is y equals x squared. Okay, so whenever we're graphing, that's what we'll graph first. And we'll keep it in our graph. So if you have a graphing calculator, you want to put that into your first graph, y1, and just leave it in there and then put everything else into y2. And then you just delete out, put it back into y2, and just keep your y1 as x squared. So if I were to graph y equals x squared, I could get that out and graph it. I could either sketch it or look at the table and get points. And when I get those points, I'm going to see that the parent is at 0, 0 is the vertex. Okay, then it's going to go over 1, up 1 in both directions. And then it would go over 2, up 4. 1, 2, 3, 4 in both directions. And the parent looks just like that. Okay, make those a little bit bigger. All right, so the next ones I'll make a little bigger. Okay, so now I want to graph the second one, which is y equals x squared, or negative x squared. And when I put that in and graph it, it yields this graph here. It'll be just the opposite. So over 1, down 1, and over 2, down 4. So it's going to look just like that. So it took it and it flipped it. Well, in math, we call that flip. When there's a negative out front like that, we call that a reflection. And this is being reflected up and down, so that is a reflection across the x-axis. Okay, now in our second group, you'll notice that we're still comparing to the parent. So we can regraph that parent, same coordinates. Over 1, up 1, both directions. Over 2, up 4. Okay, and then we put in our first one, which is y equals x squared, 2x squared. And when I graph it, I'm going to see that it's going to actually double it. So it's going to double my y's. So it'd be over 1, up 2 with the same, it'll be the same vertex, but then it would be over 2, up 8 instead of 4. So it would go like this. So I can see that it is much taller than the parent, okay? It's taller, steeper. We call that a stretch. So this is stretched by factor of 2. So with that being in mind, when I put in the next one, the 1/2 x squared, and I graph it, it's going to do just the opposite. It's going to flatten it out more. Okay, so when it flattens it out more, that would be same vertex. It's going to be the same vertex. But then it will be over 1, up 1 in both directions. And then it's going to be over 2, up 2. So it's half the size. I'm sorry, over 2, up 2. Both directions, not the over 1, up 1, sorry. And then it's going to be over 2, up 4. I'm sorry, I said that wrong again. Instead of over 2, up 4, it'll be over 2, up 8. So it's going to make it nice and wide coming out. So whenever it flattens out a graph like that, we call that a compression. So this is a compression by factor of 1/2. Okay. Now notice on the next ones, it's the same thing, same parent. So I graph the parent over 2 up 4. The parent goes like that. Okay, and notice on all of these, they all have x squared and x squared, but then they have, the first one is adding 4, second one is subtracting 5. So when I put that in, I see that it takes the parent and just moves it up 4. So it's going to take the exact parent, move it up 4. 1, 2, 3, 4. Same from there, over 1, up 1. So it's the exact same size, width, height as the parent. Over 2 from that vertex, up 4. Okay, so exactly the same. So that is, and this is a typo here. It should be a +4 right there. So this is a shift up 4 units. So with that being said, the next one should be a shift down 5 units. And if I put it in my calculator, I would see that sure enough it does do that. It takes the parent, moves it down 5. It's my new vertex. From there, it's the same size as the parent. Over 1, up 1. Over 2, up 4. So it's just a shift up and down. Anytime it's add or subtract to the end is a shift up or down. Now the next page here, we see the parent again. Over 2, up 4. Okay, now on this one, I see parentheses. Now parentheses mean that it is going to be a horizontal shift, and it's always the opposite of what's in parentheses. So in this case, with it being a +3, it's going to take the parent and it's going to shift it to the left 3. It's the opposite. So it takes the parent, shifts it over 1, 2, 3 to the left, and from there it's exactly the same size. Over 1, up 1, over 2, up 4. Okay. So that's a shift left 3 units. So that means that on the next one, that would be a shift the opposite, shift right 4 units. So it takes the parent, shifts it to the right, 1, 2, 3, 4, and then it's the exact same size from there on. So over 2, up 4, and it goes like that. Now, all of those things we just did, the rules are written right here. Where K is my vertical shift. That is up and down. If it's exactly as it says. So if it's +4, it moves up 4. If it's -4, it moves down 4. H is inside the house here, or inside the parentheses. It's always the opposite. So if it says +4, that means I move left 4. If it was -4, I move right 4. The A, which is what's multiplied out front, is going to either stretch. In this case, on here it says shrink, but we also call that compress. So if it is a number greater than 1, that is a stretch. If it's a number that's between 0 and 1, so a fraction, then it's a compression. If it's a negative in front of it, that is a reflection. Okay, so now we're going to say what is happening on number 5 to the parent to get that graph. So in this particular case, I notice at the front it's a negative, so this is a reflection across x-axis. And I'm just working from left to right, so I see that there's parentheses, so I know that's a horizontal shift. It's a +2, I know it's the opposite, so it would be a shift left 2 units. And at the end, it's subtracted by 1, so that is a shift down 1 unit. Okay. The next one's being multiplied by 1/2 on number 6, so that's a number less than 1, so that is a compression. So compressed by 1/2. And then I have parentheses, so that's a shift left and right, and it's the opposite, so that would be a shift right 1 unit. On number 7, I notice it's being multiplied by 2 to begin with. That is greater than 1, so that is a stretch by factor of 2. And then there is no parentheses, so no house as I call it. So there is no left and right or horizontal shift, but it is a 1 added to the end, so that is a shift up 1 unit. Okay, number 8 has a little of everything. On number 8, I have a negative out front, so that is a reflection. Across x-axis. And then I have a 3 being multiplied, so that's a number greater than 1. Even though the negative's out there, we used it with reflection, so 3 is greater than 1, so that is a stretch by factor of 3. Then I have parentheses, and it's opposite. That's a horizontal shift, so that would be a shift right 4 units. And a positive 2 is being added to the end, so that's a shift up 2 units. Okay. Now we're going to take it from the writing back to an actual equation. So it's given it to us, a description, and I've got to write what happened to the parent here and write the new equation. So it's shift left 4. So in order to shift left, that's horizontal shift, so I got to have parentheses. So y equals parentheses. To go left 4, that'd be +4, because I always know it's opposite inside, squared. Up 1 is literal, so it'd be +1 added to the end. Okay, number 10. Stretch by a factor of 5. That means I have to multiply by 5 out front. Shift right 6. So that says I have to have parentheses. And to go right, that would be a -6. And up 2 would be 2 added to the end. Now number 11 is a reflection. So that's y equals a negative. Across the x-axis and a shift down 5. So there is no left and right, so I don't have parentheses. So I go ahead and put my x squared. Shift down 5 would be -5. Okay, number 12 is shrink by a factor of 1/3. That's the same thing as saying compression. So it's multiplied by 1/3. It's also reflected, so I got to put a minus in the front. And then it says shift right 7 units, so I have to have parentheses. To go right, that's a subtract 7 squared. And down 3 would be a -3. Now number 13 and 14 is asking us to manipulate the given equation. So on this particular one, on number 13, it says go up 4 units. I know my up and down is outside, So that would be a plus 4. Outside, I'm going to add to the negative 1. And left 2, I know that has to go, in order to go left and right, it has to go inside parentheses. Left 2, the opposite of that would be a plus 2, so I'm going to add it to the existing 2 that's already there. And I'm going to write my new equation. Y equals x, 2 plus 2 is 4 squared. Negative 1 plus 4 is negative 3. Okay, number 14, I want to take that equation and I want to shift it right 4 units. That tells me I've got to have parentheses. Right 4 would be a negative 4 squared. And then up 2 units, that tells me add 2 to the existing 3, which would give me 5. The problems we will do on this, A66, we'll be doing numbers 1, 4, 7, 9, 12, 14, 16, 17, and 20. This concludes the notes for A66. I'm sorry, for notes for 6.6, yes.